The topic of this tutorial is proportional and graduated point symbol maps. Like color, as we have seen in the previous sections, we can also display our quantitative attribute data using dots or point symbols. But it doesn't necessarily have to be a dot symbol. It could be a circle, rectangle, or triangle. There are generally two types of point symbol maps in ArcGIS Pro: graduated symbol maps and proportional symbol maps. The common thing about them is all of these two types of maps represent quantities using dots, and they are shown in the center of each polygon, proportional to the value they represent. However, there is a difference between them, as we shall see later. First, proportional symbol maps. The main idea behind proportional symbol is the larger the symbol on the map means the more something is, depending on what it represents. It could be population or number of clinics or health facilities or whatever. Here is an example of a proportional map of the urban population in the world. You see, each country has its own rate of urban population, and each symbol size is therefore unique. In Africa, for instance, here, one can tell at a glance that Nigerian cities like Lagos and Abuja, or Cairo, or Kinshasa, they're more populous. And also Addis and South African cities like Johannesburg. But we can compare between the urban populations in Africa and in the world. But unlike graduated symbols, there are no classes. Symbology here is unclassed. Each dot is proportional to each country's urban population in terms of number or magnitude in this example. Second, graduated symbol maps. While proportional symbol maps symbols with absolute magnitude, graduated symbol maps divide quantities into classes first. It creates classes using data classification techniques we discussed in the tips and notes sections. Here, like proportional symbols, here we have few distinct classes revealed by graduated symbols. The examples we see here is the HIV/AIDS rate in sub-Saharan Africa some years back. The symbols here do not show actual rate values in each country, but rather the class group they belong to. Here are the symbols and sizes for the 5 class groups. There are not about 50 differently sized symbols here, but only 5 types. To demonstrate how we can prepare both types of symbol maps, please open tutorial 2-5 project. Again, the map shows the 10 subcities in Addis. Data shows information among other things like population, but we are interested in population this time. We have seen in the previous sections single or unique values for categorical data and graduated colors in tutorial 2-4, and now graduated symbols. So go to symbology, and for symbology, please pick graduated symbols this time, and uncheck topographical map to see the symbols better. So for the field, now population, because we are interested in it now. For normalization, leave it as that. For methods, you can experiment with different kinds of methods, but for now let us go for the default natural breaks or junks method. And here are 5 classes as default, from smallest to largest in terms of population. Leave it as 5, that's okay. You see, there are 5 classes. Akaki is in the first group, Arada, Lideta, and Kirkos, they are in the second group. Addis, Katama, and Gulale are in the third group. Nafasilk, Bole, and Yeka, they are in the fourth group, in the same fourth group. Kolfe is in the fifth group. They are shown in the map, and their size is proportional to the size of the population class group they belong to. By the way, you can change the properties of the symbols here by clicking on this template, and here you can choose any other alternative symbol if you want to. There are different kinds of options. You can play around with it, go back, okay? Anyway, this is graduated symbol. Let us now see how the proportional symbol map differs from the graduated symbol using an example. Now here, pick proportional symbols and then click population. You see here, there are no classes here. All the 10 subcities have unique sized symbols, each proportional to its own size. You remember in the graduated symbols, these 3 subcities, these 3, were in the same category or in the same class. But here they have their own sizes, proportional to their own magnitude. And also, these 3 subcities were in the same category or class. And also, these 2 subcities were in the same category. But here they have their own sizes and magnitudes. So, graduated symbol map is classed and proportional symbol map is unclassed.